She is responsible for oversight of tailings dams at Newmont's global operations, including the development of standards and guidelines, overseeing governance programs, conducting risk assessments and reviews, and leading implementation of global industry standards and tailings management. As founding chair of the Tailings and Management Waste Committee of the Society for Mining, Metallurgy and Exploration, formed in 2020, she actively works to raise awareness about tailings management through programs and training. Kim served as the managing editor of the first edition of SME's Tailings Management Handbook, a life cycle approach publicized in 2022. She is an active member of the International Council of Mining and Metallurgical Tailings Work Group and the advisory boards for the Tailings and Industry Waste Engineering Center and EduMine. Formerly served in various leadership roles in the Geotechnical Professional Business Association, including being the second woman on the board of directors and founding the Tailings Engineering Record Task Force, which results in the publication of the proposed best practice for the engineer of record for tailings dams. In 2020, she was named to the 100 Global Inspirational Women in Mining and received the SME's President's Individual Citation Award. In 2022, she received the Environmental Stewardship Distinguished Service Award from SME's Environmental Division and was selected to be featured in the temporary exhibition Pioneering the Field Women in Mining at the National Mining Hall of Fame and Museum in Leadville, Colorado. Kim served as the chair of the steering committee for the recently announced Geostable Tailings Consortium. Please welcome Kim.
Well, thank you for that very long introduction. I told him he could cut that short, much shorter. And apparently I'm pretty clumsy and don't see stairs, so safety hazard over here or safety hazard here, either way, I'm very clumsy. But anyway, I'm humbled and honored to be here, so thank you very much for this invitation. Theo, thank you very much for inviting me to participate here. This is a conference that I've heard about for years, that I've always wanted to go to. Australia is kind of like a second home to me in just a way. I mean, I lived in Perth back in 2008, 2009 for only 6 months, but it was long enough for me to say it is like a second home. And coming back to Australia, I love it. I want to come here as often as I can, and it really is a second home. So anyway, today I'm going to talk about leading advancement of the geostable tailings technology through industry collaboration. But that'll kick off a bit the panel that will follow on technology in general. But before we go there, you know, I guess I've learned a couple of things over the course of the past couple of days. As the keynote speaker, I'm in charge. I have the stage. The floor is mine. What Chris Hatton taught me is I can say whatever I want. And what David Williams taught me, I can talk as long as I want. So watch out, we'll see what's coming. But yesterday morning, some people jested a little bit like, who's this guy? I don't know this guy. Hey, this guy, why don't you stand up? Who is the poster child for Mine Waste and Tailings 2023? It's no other than Tim Bell of North Parks. Tim, where are you at? Stand up. Wish to embarrass you. So I just want to say a little bit more about Tim. He truly is one of the best tailings operators I have ever had the pleasure to work with. Yesterday, there was some conversation about probability of failure versus factor of safety, and it all talked around design and construction. You know what? You can have a well-designed and well-constructed tailings dam, but if it is not operated well, it'll fail on you. But if you have an excellent operator, you can have a really poor design, really poor construction, and that operator can save the day So a good tailings operator truly is worth their weight in gold. So thank you, Tim. So that's a little bit of a segue to how do I know Tim? Tim and I worked together. I looked through my archives, Tim, to see if I had a picture of you and I together in our orange suits, but I didn't. So this is the best I could do, our selfie from yesterday. But I worked for China Moly before I joined Newmont 4.5 years ago. And with China Moly, they had operations in Brazil. So one thing that people don't really know about me is that I was doing a whole lot of work in Brazil up until the tailings failure at Brumadinho. So much so that I was in fact in Belo Horizonte 6 days before the failure on this hill overlooking the area that the failure would occur. I was on my last flight home to Denver, Colorado, when that failure occurred. I turned on my cell phones, and these are the messages I was receiving from my friends and colleagues in Brazil. A tailings dam just failed. Hey, do you remember where we were on Sunday? We could see that in the distance. Another former colleague that had left China Moly to go to work elsewhere, he said, hey, because this tailings dam just failed, we had to stop operations because our water supply was cut off. So people like to say, oh, Kim, she is so passionate about tailings. I'm not passionate about tailings. How do you get passionate about tailings? I'm passionate about trying to do the right thing and trying to drive improvements to this industry. And I believed that where I could be most effective in driving these improvements was from the inside. So I've been with Newmont now for more than 4 years. So that's a little bit about me. And now we get to the boring stuff, the actual presentation, the part that I prepared to talk about today, which is really about this Geostable Tailings Consortium. Who are we? What are our objectives? What are we setting out to do? How might this work tie to other global initiatives that are out there? Talk a little bit about the work that was advanced by Goldcorp prior to Newmont's acquisition of Goldcorp in 2019, and then a little bit about what we're starting to do. And we are just getting started again within Newmont to study geostable tailings. So, introducing the consortium. Who are we? It's a joint multi-year initiative of 8 leading mining companies that aims to develop and implement improved approaches to tailings and waste management that prioritize safety, sustainability, and environmental stewardship. You can see the companies that it's comprised of: Antamina, Barrick, BHP, Freeport-McMoRan, Goldfields, Newmont, Teck, and Vale. And we're also supported currently by Dr. Ward Wilson from the University of Alberta. So I do have a little funny here. When we were putting together the press release for the Geostable Tailings Consortium, it was actually the day that I first learned about ChatGPT. So the person that was supporting me, he said, hey, have you heard of this new tool, ChatGPT? So I have no idea what you're talking about. He said, well, hey, I'll just show you. Let's just say, hey, geostable tailings, press release. He typed in like 6 words. It produced a press release that was 80% there. I only had to make a few minor tweaks. And then it had to go through all of the other consortium members to get approval, but there you go. ChatGPT can work. It can streamline things quite a bit. So anyway, we had press releases go out mid-April, early May, but the consortium itself was actually kind of a long time in the development. It takes a long time with this many companies to get through all of the contractual phases and agreements and how are we going to share information, et cetera, et cetera. So after Newmont acquired Goldcorp in 2019, some of these companies were talking to Newmont, hey, Goldcorp was advancing geo-waste, eco-tails. What are you guys going to do? Are you going to do anything about it? Are you going to let the technology die on the vine? And so it took a little bit of time, but we started talking about forming this consortium back in 2020. So here we are, 2023, finally announcing it, finally getting traction. And as the chair of the steering committee, this really was one of the first things that I did, because I only became chair of the steering committee earlier this year. I said, hey, if we announce to the world who we are and what we're trying to do, it's going to hold our feet to the fire and hold us accountable to actually put our money where our mouth is and start doing something and driving this technology. So what are the objectives of the consortium? I presented this to the steering committee just last month after I had already presented it at Tailings 2023 in Santiago. And I said, hey guys, I thought maybe we should frame what our objectives were, because, well, I wanted to tell others what we were doing. So here's my first cut at what I think our objectives are. Do you guys agree? So they're generally aligned. So first, what we are. We're an assemblage of leading mining companies. It is through this collaboration and commitment that we view that we can move technology more rapidly. We are working to establish a robust knowledge base. I'll talk a little bit about geostable tailings, what they are, but the single term, commingling. I mean, really, it's commingling. Commingling of tailings and waste rock. This is not new. There's lots of data out there. There's people that have been commingling for years. So there's data for us to pull from. And so we're working on curating that research and data and developing a searchable database that we will continue to develop as we get more data. We have also, as part of the technical committee for the consortium, developed a draft of the guideline for the construction, testing, and evaluation of geostable trial pads. The purpose of this guideline is to support alignment in our approach to development and testing so that we can get meaningful data from our tests. So I have a little question here. Will this be shared with the general public? That's under discussion right now. Not all consortium members are in agreement with sharing it, but come on guys, if we don't share the information amongst ourselves, how are we all going to improve? So I think I'll be pushing for that one. So each of the 8 member companies have made a commitment to plan, construct, and monitor field trials. And what we've been trying to do is a bit of a landscape. So we have different commodities, we have different climates, different geochemical considerations and geotechnical considerations for the waste rock, for the tailings. So we're trying to canvas what everybody is looking to do and to develop more of that broader view as to what the realm of possibility is in this space. And so each member has agreed to execute field trials within defined tranches. So about a third, I know there are 8, it's hard to divide into 3, but a third have committed to build trial pads by about the end of this year, early next year, and then the next tranche a year later, and then the next tranche a year later. And so we expect that it's going to take several years for us to get the data that we wish to have from these field trials, particularly where geochemistry is a concern. But in addition to focusing on the geostable tailings technology, we're using this platform for additional collaboration and sharing, not just focused on geostable tailings. For instance, one of the member companies recently did a landscape review of all of the filter manufacturers out there and what were the largest filters that they had and what were the throughputs that they could manage and whatnot, and shared that information with the consortium. So we're using this as a platform to share information with each other. So most of the companies, I say most because Antamina isn't officially a member of the International Council on Mining and Metals, but it is a joint venture and most of the joint venture partners are, so in a way they are an ICMM member company. But all of the other consortium members are members of ICMM. And ICMM has set several tailings aspirational goals several years ago. And one of the goals that they set, it was set by the CEOs of the ICMM member companies in late 2018, is that members agreed to work collectively to advance progress over the next 10 to 15 years towards developing improved and cost-effective alternatives to conventionally manage tailing storage facilities that will reduce the risk of catastrophic failure. In September, you may have seen ICMM announce that they published the Tailings Reduction Roadmap, which I'm showing here. Yesterday, there was quite a bit of discussion around risk assessment and the as low as reasonably practicable. Sorry, Lisa, not possible. Anything is possible. So it's as low as reasonably practicable, the ALARP principle. One thing that came up is, well, as long as you have a dam, I mean, don't you still have risk? Well, yeah, but some actually argue that industry has failed if it's produced tailings at all. So Dr. Priscilla Nelson, she says the best tailings dam is no dam at all. I think we would all agree that when it comes to tailings management, if we can eliminate dams, we would be eliminating a lot of risk. And you may wonder, if you haven't looked at the Tailings Reduction Roadmap, what types of things does it entail? It looks at the beginning of the mining life cycle, trying to reduce the amount of ore or low-grade ore, or we'll say waste, that goes through the process plant that then produces tailings. So as much as we can reduce at the front end, the better we are at the end. And then we look at the uranium industry, at least in the United States, most uranium that's produced in the United States, there's no ore, there's no tailings. It's all done through in situ recovery. So there are advances in that space as well. Well, I have to throw in a slide about the Global Industry Standard on Tailings Management, of course. And I could talk about the GISTM until I am completely blue in the face, quite literally. I know those 77 requirements inside, outside, upside down. But when it comes to improving technology in the tailing space, the GISTM is only but one driver. In fact, the word technologies is used 5 times in the GISTM. But I've put up here requirement 6.6, which states, include new and emerging technologies and approaches, and use the evolving knowledge in the refinement of the design, construction, and operation of the tailings facility. But again, the GISTM is just one driver. It's really the industry's obligation to manage its tailings and waste responsibly that's the main driver for improvements in tailings technology. Okay, I've been up here, I've been talking for a while. I haven't really told you what geostable tailings are, so I guess I should do that. So what are they? There's a couple of different structures that are recognized for commingling of tailings and waste rock. The first structure, these are both published by Ben Wickland, who got his PhD with Ward Wilson. The first structure is a tailings-dominated matrix where hard rock particles float within the tailings. The second structure is the rock-dominated matrix, where the waste rock itself is in particle-to-particle contact with tailings, only filling the void space. And we can argue that if we're looking for a geostable tailings where it is not confined, we're probably focusing on that second structure. So what are geostable tailings again? We're looking at the tailings and the issues that it presents. So by blending the tailings with the waste rock, we're leveraging the best properties of each of these materials. Tailings, they're typically saturated. They have low shear strength, low permeability, and as we see time and time again, physical stability problems. Waste rock often has acid rock drainage risks, typically unsaturated, but it has very high permeability, high strength, high stability. But it does provide ideal conditions for oxidation and leaching and production of the acid rock drainage. But you mix the two together, and you have the potential to reduce the acid rock drainage potential, as well as metal leaching risks. You may eliminate requirements for a dam. You reduce your disturbance footprint. So if you think about waste piles here and tailings facilities there, if you can mix the two together and put the tailings in the void space of the rock, you have a much reduced disturbance footprint. You have the ability to progressively reclaim the slopes of the geostable tailings pile as you go. And if we think about geostable tailings as being just a material that we can use as borrow elsewhere, I mean, we could use it as cover material to support closure and support some of that oxygen reduction into facilities. I don't need to talk much about these. We all know what the concerns are about conventional tailings management. Unfortunately, here we are, 2023, and tailings management has not changed substantially over the years. We continue to store wet tailings behind dams that are raised periodically and failing at an unacceptable rate. We need to think about our social license to operate. Tailings and related water management issues may jeopardize our social license. Stakeholders, they have lots of concerns these days. Traditional wet storage is often challenged by our regulators and other stakeholders. If we look at tailings production trends over the years, I mean, back in the early 1900s, we were producing, maybe tens of tons per day of tailings at a mine operation, increasing to 100 tons per day, thousands of tons per day. Where are we at now? We're upwards of 500,000 to 1 million tons per day of tailings at some of our base metal operations and whatnot. The trend of tailings production is absolutely staggering because we're constantly being forced to chase the lower grade materials to continue to maintain similar levels of production of the commodity itself. And those tailings production trends pose us a lot of challenges. How can we do things better? I think during the panel there's going to be quite a bit of discussion around filtration. And I will say filtration, it is not dry stack. Dry stack is a misnomer. There is no such thing as dry tailings. It's filtered tailings. In the Tailings Management Handbook, we use the term dry stack one time, only in that context, to explain that it was a misnomer and that we were only going to talk about it once in the entire book. And the book's 1,000 pages long. But with tailings filtration, there's several concerns around that challenge us in order to filter our tailings. Time. When we think about large-scale filtration, it can lag other processes. We can crush the ore, we can mill the ore a lot faster than we can filter it, so it slows us down in our process. It's expensive. At least we hear that it's expensive all the time. Yes, you have your upfront capital costs, but you have pretty extensive operation costs. But then if we think about the full life cycle of the costs, and if we could get away from that awful net present value approach to look at our projects, I think that it would be pushing us towards much improved technology because people fail to look at the closure costs. And these conventional tailing storage facilities are costing us a lot of money to maintain in the long term. What's the long term? Perpetuity. It's forever. I mean, we need to be thinking better. We need to be thinking more holistically. We need to be pushing the industry to do better. Filtration's also challenged by scale. Up until a few years ago, the largest filtered tailings operation in the world was only upwards of 20,000 tons per day. Didn't I mention that we're producing tailings at like 500,000 to 1 million tons per day? But the largest filtered tailings plant was only, around 20,000 tons per day. When people do their option studies, the first thing they say is, well, nobody's done that before. We're not going to be the first. It's impossible. It's not impossible, but that it often falls out as impossible because people just aren't willing to go there. But we do need to continue to push that technology. And then another concern with filtered tailings is you have dusting. Okay, so you have this drier material. Yes, it can dust, but there's ways to manage that as well. So Goldcorp, they talked about EcoTails GeoWaste. And their mission statement for EcoTails stated that they would create an economical and environmentally sustainable solution to tailings in large-scale operations by optimizing water reuse and producing a stable GeoWaste. Well, we rebranded it, right? I guess we didn't like the word GeoWaste. I mean, GeoWaste can be any waste. Geostable tailings, I mean, then you're starting to think, oh, geostable tailings. Okay, so we've got tailings. We want something that is stable geotechnically and geochemically. Okay, geostable tailings. So what was Goldcorp's proposed solution to produce their GeoWaste, or geostable tailings? They divided it into 3 parts. The first part was large-scale fast filtration. So the thought is, you push those tailings through the filters really, really fast, and you don't need to dewater the tailings to the extent that you would if you're placing filtered tailings by itself in a stack. So it can be wetter, and you can push it through faster. I guess hence the term eco-tails. It's cheaper tailings, maybe. GeoWaste, that's where the commingling comes in. So their approach considered bringing the 2 waste streams together on conveyor and having it drop a few times and pick back up. And through that dropping and picking up process that they indicated would be maybe 3 drops, would get you to a pretty homogeneous commingled mix. And then the third component of this is the stack itself. We convey it, we stack it, there we go. It's geostable. So even though this technology can be applicable in lots of different commodities at lots of different throughputs, the focus of Goldcorp at the time was for those high throughput, high tonnage projects. So a little bit about what Goldcorp did. They had 2 key technical objectives of their GeoWaste. The one was to produce a material that was generally unsaturated. So they wanted it to have a water holding capability, but still act more or less as a sand gravel pile, not as a tailings pile. And they wanted it to reduce oxygen influx. So they built GeoWaste trials, whoops, I went the wrong direction, at the Penasquito mine in Mexico and the Morrison mine in Guatemala. You see, with each of these, there's 2 piles. So one of them is a GeoWaste, and the other one is just waste as a control pile to understand how the GeoWaste parameters compared to the waste pile parameters. With both of the GeoWaste piles, Penasquito and Marlin, there was no measurable seepage from the GeoWaste, nor was there any noticeable dust generation. But with the waste rock control piles, there was seepage encountered at Marlin. So Marlin, much wetter environment than Penasquito. So yes, okay, there was seepage. That would be expected. And then when they measured the oxygen ingress into those piles, they found that the GeoWaste piles reduced oxygen content to 0% at depth from an initial 21% in less than 6 months, while the waste control pile had more than 15% oxygen contained within it. So I'll talk very quickly about what we're looking at now and how that differs from what Goldcorp was looking at in the past. And we are in the very early stages of working out what we think we wish to do. And the first step was, what are the potential use cases? So we looked at all of our operations. Where might this be a good solution for an operation? And even though we've got a few, we did come back to Penasquito. Penasquito, they produce tailings at about 120,000 tons per day. It is a very large tailings dam, as you see here, and growing considerably more. So we considered 5 different potential use cases for geostable tailings, or I guess we are considering 5 potential use cases. One of them is to produce a material to place as an initial closure cover over this existing very large tailing storage facility. It's 11 kilometers to drive around this facility, if that gives you an indication of scale. And that initial closure cover would just provide that trafficable layer for development of a final closure cover and development of a water shedding cover to support closure. The second scenario, you can see that we have pretty steep slopes. Can we close the facility with those steep slopes? Maybe not. So closure studies are underway currently that are indicating that we need to have flatter slopes. So maybe we could use the geo-waste to support flattening of the slopes to get us towards closure. Another option is taking the geostable tailings and placing it internal to some of the waste rock piles on site. Another scenario, yes, we've got plenty. We have all of these waste rock piles. They're potentially acid generating. Maybe we can cap them with geo-waste to support their closure and try to reduce some of the oxygen ingress. And finally, maybe we can just place it as a pit backfill to extend our life of mine tailings and waste rock storage capacities. So because Goldcorp did work, we're not starting from zero, but there are some changes. So the former test pads were quite small, but the key thing is it was potentially acid-generating tailings and non-potentially acid-generating waste rock. Things have flipped a little bit. Several limitations that we saw with the past work. You can see these are very small trial pads, only 25 meters by 25 meters with really steep side slopes. So these small trial pads were dominated by the side slope influences. The majority of our waste rock moving forward is potentially acid generating, not non-PAG. The field trials were focused on geochem, and there was no seepage measured because of the arid environment. But there were several successes. There was a lot of testing done geotechnically to understand the tailings in the waste rock. And with the geo-waste pile, it was demonstrated to have a high water holding capacity and considered sufficient to limit oxygen ingress. So moving forward, in addition to having PAG waste rock, we're looking at, whoops, wrong button. Oh, I guess I don't have, that's okay. I don't know how to use a laser pointer. Anyway, if you look here at the flow chart at the top, 90% of our tailings is actually not potentially acid generating. But if you mix it with that 10% stream, then the overall tailings become potentially acid generating. So now we're looking at it like, well, wait a minute, why don't we manage that small stream in a different way and consider just the 90% for the geostable tailings? So we're working to develop baseline geotech and geochem data. We're trying to also improve understanding of the geochemical behavior and the geotechnical properties. But a key difference that we're looking at here is at Penasquito, we have 2 cyclones. And in this arid environment, that may be a pretty efficient way to support much of the dewatering. So we're looking at using these existing cyclones on site as a cost-efficient method to dewater the tailings. We have an environmental permit that's actually still in place to build trials. So we'd like to get some trial pads built pretty quickly. We're proposing 3 or 4 trial pads. You saw that Goldcorp, they landed on just 1 geo-waste mix. So we want to test a few different variables. And we're going to build much larger trial pads to try to understand better the overall properties and get away from some of those side slope influences. And again, back to the PAG waste rock, non-PAG tailings, mix them together. Hopefully we can get to a geochemically stable mix in the long term. So path towards full-scale implementation. We have only barely begun. We've thought about our future use cases. We're working on some lab testing to supplement the lab testing that was done before. And we're also working to design the test pads that we hope to start building later this year. Over time, we'll have our test pads built, we'll be monitoring those, and we'll work on commercial demonstration of the technology before moving to full-scale implementation. So this will probably take quite a few years. And I see Steve is getting anxious, so don't worry, I am coming to a close. So, in closing, Steve, it is through industry collaboration that we can advance tailings technology at an accelerated rate for the betterment of the industry as a whole. I just talked to you a little bit about what we're looking at within Newmont. You may have seen some other recent presentations as part of the consortium. Antamina presenting on the work that they're doing. Goldfields recently presented the work that they're doing for one of their sites in Ghana. And ending with a picture of the book. Yes, it too was very much a collaboration effort with more than 100 people contributing to development of this 1,000-page book. But what I wanted to flag to folks in this room, because you might not realize this, is that if you're a member of AUSM, you can get the book for SME member price. You don't have to pay for non-member price. I'm giving you the code right here to do so. It's GMPA 2022, GMPA 22. So what's GMPA? It's a lot of organizations. So just in case you ask the question, what's GMPA? Back a few years ago, after the failure at Brumadinho, they formed the Global Action on Tailings. So lots of people talking to each other. What can we do? What can we do? And yes, I've talked to David Williams a lot on these GAT calls and others. But final slide. As we think about tailings technology and our journey, what is the road ahead? And who dictates that? It's all of us. But we need to be working cross-functionally, collaboratively. We need to be working industry, consultants, suppliers, manufacturers. We need to be working all together to improve technology moving forward. So with that, thank you very much.
Thank you, Kim. That was insightful. Thanks very much. Guys, we're running a little bit late, but we're going to have a few questions. And I guess the first question, I'm just going to start off quickly about the challenges that you have with mining houses, obviously, is getting the finances. You know, the shareholders want to return on their investments. And so we have a challenge in basically getting approval for these large projects. So from your point of view, what do you believe are the biggest challenges for the geostable tailings to move ahead?
That is a really good question. You know, I think you keyed in on it, which is always finance, the dollars and cents. And so it does typically cost a bit of money to improve technology. And trying to get the buy-in to move forward can be an uphill battle at times. But we need to be educating those at senior executive levels on how this move towards improved technology improves the industry as a whole. And it may look like a lot of money right now, but if we think about the long term, it really isn't. I mean, you know, I work for Newmont. We have a lot of legacy facilities, a lot. And as we're talking about the global industry standard on tailings management, we have 11 that are priority that we have to disclose and be in conformance by August. Guess how many that we operate and own that we have to have conformance by August 25? 53. 53 additional tailings facilities. John over here and Glenn, wherever he is, they're part of our legacy team. They deal with a lot of these facilities. Now, not all 53 of those are legacy, but legacy is an important area within Newmont that is looked at as nothing but how much is it costing us, how much is it going to continue to cost us, and what we're seeing is that the price of managing these legacy facilities continues to increase and escalate as we have acid rock drainage and we're requiring more lime to treat and whatnot. So if we can get our executives to walk with us and look at the long term and understand that view, then we can peel them back to get them to help support us in driving those improvements. So within the Geostable Tailings Consortium, we recognize that we need that high-level approval and understanding within the organizations. So the steering committee for the consortium has that linkage to the executives in the various organizations to get that support and buy-in. So that's one way that it's helping. And I don't know if I completely answered the question there, but I'm on another soapbox, so why not?
All right, we've got time for one more question. Kim, what are the future plans in moving into third world countries like PNG, especially with Newmont's recent merger with Newcrest?
Oh my goodness. Can I just say no comment? I don't think I can comment on that.
Well, guys, put our hands together.
But I do have to say one thing. The GISTM does not apply.
Okay. Guys, put our hands together. Thanks, Kim. Thanks very much. Thank you.
Thank you.
I'd like to call upon our facilitator for the next session, Theo Gertsen from Rio Tinto. Please welcome Theo.
Thanks, Steve. Welcome, panelists. We'll wait for a moment.